Welcome to the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza. Today, we'll discuss building and scaling AI-driven transformation in manufacturing. And today's episode is special because we'll be talking to someone who has got real-world experience going from pilot to over $100 million in annual improvements. My guest here is Jonathan Alexander, who is the Global Manufacturing AI and Advanced Analytics Manager at Albermale Corporation. So, Jonathan, thank you so much for taking the time to join us today. Welcome to the show.
Kudzai, I appreciate you having me on. Always exciting to talk about digital transformation and AI in the manufacturing space. Incredibly passionate. I'll do my best to contain myself as we talk about it, but no promises.
Oh yeah, absolutely. So maybe let's start from there. Can you begin by introducing yourself to our audience and tell us a bit more about your role in your company?
Sure. So I lead our AI and analytics efforts globally, and I'm within the Manufacturing Excellence organization. So we support all of our global sites with best practices and standards. We're kind of like internal consultants, so that with a wide range of specialty skills around maintenance, equipment reliability, mechanical excellence, materials and construction, engineering, electrical, and a wide variety of others, continuous improvement, root cause analysis. And our team has a focus around a blend of AI and analytics technology, but blending that with these foundational elements around Lean and Six Sigma and continuous improvement. So we found that doing the technology just by itself didn't really give us much value and return in the company. We didn't see much difference. So being able to pair that with things that are really proven in our industry for many, many decades, and we combine those two together, and that's where we found the perfect blend to be able to not only scale these technologies globally, but also scale the business value.
Awesome stuff. So really looking forward to unpacking all of that with you today here. So to start, let's I'm sure you've read as many reports as I have around this idea that a lot of manufacturing companies are struggling to scale their AI initiatives out of the pilot phase, and much of it is really attributed to data challenges. So can you maybe start by breaking down for us on what you see as being the key data challenges that manufacturers face when trying to implement AI at scale?
Yeah, of course. This is a common challenge. So if you're in this boat listening, you have some pilots and you're struggling to scale, you're struggling to see get more users using it more routinely like you would expect them over many years. And if you're also struggling to find ROI and create business value from that technology, what we found initially is being able to, or I guess what helped us is switching from what we think about a technology-based vision to this relentless focus on business value. So LNS Research has this has done some research around this, and they call the piece in the middle where people make that switch from the technology based to the business based, and those people that make that switch they navigate what they call this transformation chasm. And that's where I personally have internally kind of branded that as pilot purgatory. And it's the place where your budgets go to burn and your dreams go to die, as a funny way of thinking about it. But it's very common. And so if you're in that space, I think you're in the majority. And there are many traps. So I can talk all day about this. So you asked about the data elements around it, so I can maybe speak to that. I think some people worry about manufacturing process data and their instrumentation. So if you've been in a manufacturing site that's been around maybe since the 1950s and some earlier, that's 70-year technology. And some of those assets are original. Now, most have been modernized, but people worry about those instruments. Are they reliable? And if you think about maybe one manufacturing site, like think about a large oil and gas refinery, they may have, I don't know, 500,000 instruments. So they think, if I want to do AI at scale, do I have to replace all those instruments? And that's just one site. And we struggle with this. And my background's actually in instrumentation. I'm an electrical engineer by trade. So I started my career in instrumentation and electrical. And while there are some problems out there, there are some instruments that I've seen in the past that are kind of held together by duct tape, but they work. And sometimes they don't work. And from a manufacturing process, what we have historically done is our instruments were used primarily to do two things. One is to control the process, and the other is to manage risk. And those were the two primary focuses for our instrumentation and our process control. So when you design a plant and you design the automation sequencing, they look and they figure out, okay, well, I need to control the level of this tank. So I need a level transmitter. I also need a level control valve. I might need a flow meter so that I can monitor and control the feed going into that tank. But maybe they say, I don't need a pressure transmitter because I'm not controlling pressure. Now, in modern times, people wish they had those pressure transmitters because those would help with optimizing the plant and some of those machine learning models where it's important to understand the correlation between the level and the flow and the pressure. But you don't have it. So what we've done is we said it's too complicated at this moment to replace all of our instruments or even many of them. So we said we're just going to leave it as is and try to do the best with what we have. So we eliminated the need to change any of our source data. And what we said is we were going to start at the next level of what we call the data pyramid, where we talked about contextualizing our data. And focusing on the contextualization of the data is where we spent, unfortunately, about majority of our time. And if you do that right, it pays off big time. So this goes into, I know your company is big champions of unified namespace, and we are big believers in that and big advocates for that. So when I talk about contextualizing your data, it's all about unified namespace. How can you create a semantic layer on top of all this instrumentation that's telling you all these interesting signals about your process, and you can kind of think of them as a guardrail of trying to figure out where your process is, where your process was, and where your process will be. And the data tells that story if you contextualize it right.
Yeah. So maybe let's kind of like, dive a bit deeper into this idea of contextualization, because I mean, if you've been really paying attention across, the online and social networks everywhere, everyone talks about contextualization, but I've, come to realize that, people understand it differently, right? So what is contextualization really in your world? Can you kind of like give us a picture of how you view or how you approach contextualization?
That's a great question. And unfortunately, there's not really great standardization around that in the industry at the moment. And I'm hoping that that changes here soon. But when you talk about unified namespace, that's a more recent term right now that at least I've personally heard. I don't know, Kudzai, when when was the first time you can remember hearing unified namespace?
So I would say 2020, 2021,
Okay.
somewhere there. Yeah.
Yeah. So, and probably me later, maybe the last 2 or 3 years. And when we started our global digital transformation, that was in 2019. So like that concept, maybe, I don't know if it was around when it was created, or that term unified namespace, but the same concept is what we did around contextualizing our data. So we use the Aviva Pi Asset Framework system, formerly OSI Soft. And that is what we call for manufacturing process data, our unified namespace. And at a very high level, we think of our asset hierarchy. And within that, you can group your different pieces of equipment, your different instrumentations, your different production lines, all in a hierarchy. And one of the challenges we found is that people struggled really at the beginning of just organizing things. How can I think about this one tank when the tank is maybe in between two production lines? So if you have a hierarchy where you have production line 1 and production line 2, where do I place that tank? And for us, what we found is there's lots of different way and challenges around trying to have one hierarchy to rule them all. If you want to do some maintenance activities and look at your fleet of equipment, and you want to look at all of your rotating equipment and have it organized that way, that's different than how maybe a production or process engineer might look at their equipment. What if you want to look at your material inventory or your utilization? That might be something else. What about if you want to have an environmental hierarchy with all of your environmental data organized in a certain way? So what we did is we started with a standard that we wrote that defined multiple hierarchies, and they're all based on ISA 88 and 95. And so I won't go into the details of that. Your audience can look those up. But we had a production hierarchy, a maintenance hierarchy, an environmental hierarchy, a quality hierarchy. We had an SAP functional location hierarchy. And so we could place the pieces of equipment, the assets, the instrumentations, where they belong in multiple locations. And so they were kind of referenced all over. So you might have that one tank, and it might be used 10 times in a variety of different hierarchies to support downstream analytics. So we first started, in order to do that, is we defined all of our potential ideas for business cases. What problems are we trying to solve? Are we trying to think about all the reports that we eventually want to replace, all the different types of analytics solutions, all the different types of predictive modeling? And we laid those all out on the table, and then we organized the hierarchies to support all those different needs. And so far to date, we haven't found a solution, a problem that we've tried to solve that didn't already have a place that was defined in our hierarchy. So that's been pretty incredible. But it took a long time to think through those at the beginning. And most people kind of want to just jump into it and get started. So defining that hierarchy was the first step for us for contextualization.
That sounds great. Yeah, I mean, and totally agree there with you that there is a need to somewhat come up with a way to standardize how organizations do contextualize, right? Because even within the unified namespace community itself, we've got many people approaching it in many different ways, right? So the next kind of like topic that I want to talk to you about is this idea that once you've sort of like contextualized your data, so whether, for example, in your case, you've got your asset framework, how do you then sort of like unify? Because when we talk about OT, IT, data integration, in many cases we want to make data accessible across the entire enterprise to all the stakeholders who may need the data for whatever use cases they want to build. So what's your approach in sort of like unifying the data, not only to make it visible for OT folks, but across your entire enterprise?
Yeah, that's a challenge. And to be honest, we struggled with that early on. And at Albermale, we've partnered extremely closely with IT, and so our manufacturing excellence. And we actually had this role that was kind of the IT OT bridge. And they were inside of manufacturing excellence for a while, also inside of IT for a while. But we take security very seriously, and for good reasons. I mean, you've seen. I remember when the Russia-Ukraine war broke out, and I'm not going to get into the politics side of it, but
Yep.
I remember when that happened. I remember on the internet reading some story about they had a screenshot of the control system, the HMI screen of one of the, I believe it was a Russian or Ukrainian refinery. And someone had hacked into that system and were controlling some of the process control network. And when I heard about that, that moment changed how I thought about IT and OT security. So I have a deep appreciation for the security team, but it does make it challenging. You know, me personally, what I want is, if I'm being very selfish and I'm just thinking about myself, I don't care about security. Just give me all the data instantaneously. I don't want to type in a password. I want to have it on my phone anytime I want it. I don't want my screen to log off, but that's why I'm not in charge of security. Okay. So trying to find a solution to bridge that gap. The OT team or the IT team partnered with us, and there's a variety of different ways that you can do it. But one of the ways is we have a lot of remote machines. So we follow the Purdue model, where the control network sits underneath the DMZ, so it's protected, and we have very secure protocols that limit data that flows up through there, and they're protected in multiple different areas. And so we have, a secure way of viewing that data. Now, if you're at the local site, you're kind of within a local, I'd say, umbrella. You have a little bit more flexibility and ease of access. And then as you are in a global, and like me being in Houston, Texas, if I'm looking at some of our data in China or in Australia, I log into a kind of a secure environment to be able to do that. So that was what we did at the beginning. And then also what we're starting to use is we've started to become big champions of Databricks. So we're taking that data and moving that into Databricks, some of it, not all of it, to provide more access to more people and more applications. But for us, we were very focused on the OT space. So we spent the first 5 to 6 years in that kind of OT environment. And just over the past year, we've gotten into Databricks.
Awesome. That sounds great. So you really, focus more on operational data intelligence side of things, right?
That's it. Yeah. And so our bread and butter is the PI system. That's the data historian. So we live and eat and breathe pressures, temperatures, flows, levels, you name it. And that's really where our focus is, along with our LIMS or quality systems. So when we're looking at our quality data. So those are our two sources that we focused on. There's lots of other sources of rich manufacturing data, but we were already had big ambitions for what we could do with just those two spaces. So there's other teams using, looking at our SAP data for maintenance and work orders and reliability. We have data around our shift turnovers and shift reports. So now we're even looking into generative AI on how do you use generative AI to access some of that data and to enable people to interact with it in an easier way.
Awesome. So, I mean, one of the most important things, for companies, exploring AI or advanced analytics use cases is this ability to rapidly experiment and prototype. Because, as you maybe agree with me, that a lot of these begin as hypothesis, right? You've got a hypothesis about something, and then you want to experiment. So that requires that you have that kind of flexibility to be able to rapidly, prototype. How can sort of like manufacturers build a data architecture that supports that kind of flexibility to be able to rapidly iterate?
This is an interesting question, and I don't have the answer to it, but I've been thinking about this a lot over the past few years. So I'll frame up my thoughts around it before I answer the question.
Yep.
So when we started in 2019, we started with the goal of this global digital transformation. But we had been doing pilots in the digital transformation space for many, many years before that. So what we did when we started is we have all these great examples of these buckets of innovation using different types of technologies, solving different problems. So we went to all those people that had these great ideas, these great examples, and some of them had ROI attached to them and had clear business value. So we bundled all those together and we kind of organized them and looked through them. And then some were like, we first asked the question, can we scale this? And if you couldn't scale it, we kind of moved it to the side. Doesn't mean it's not valuable, but our focus was scale. And so then within the scale, what we said is, okay, here are all the technologies being used. Here are all the business problems they're solving. Here is the methodology of how the technology is organized and curated through the system and sliced and diced before it goes to the analysis. And these are type of analysis that you're doing. So we grouped all that together and we said, okay, here is a bundle of tools and a standard to tackle maybe 75% of those use cases. And then the others, we just said, they're going to have to be tackled later. So we focused on this 75% of things that we could scale. And we built what I've been thinking about is kind of like an analytics highway. So the idea is I relate it to like the interstate system that Eisenhower in the United States championed in the early 1950s. And it actually was based on the German Autobahn. But apparently in the somewhere before maybe 1919, when he was in the military, he took a trip from the East Coast of the United States all the way to the West Coast. And it took him over 60 days. Now, they had an automobile at this time and they had roads all the way through, but the roads were disconnected. Most of them were probably dirt roads. And he kept maybe he had a big, massive pothole and it totaled his car and they had to rebuild it. Probably plenty of flat tires and maybe run-ins with animals or something, and so it wasn't an easy trip. And it wasn't until 30 plus years later when and he was in Germany and saw the Autobahn. He came back to the United States. He was a president at that time, and he laid the foundation for our highway and our interstate system, I believe in 1955. And so since then, they estimate that the value of just those roadways that were already existing before, but just not standardized. And the value has been, for every $1 we spent on that, it has returned over $6. So a 600% ROI. That's the estimate. And I think that's just incredibly fascinating. And there's so many lessons that we can take away from that is by providing the right foundation. Now, those interstate systems don't take us everywhere. They they take us, if you map and how they decided to build those, they didn't just starting in one place and build that and then go say, okay, when's the next place to build? They laid out a map and they said, where does everybody live? Where are people traveling? Where do we think the future of the economy is going, where we're going to need that transportation system to get there? And so then they lay out that network, and then that really opens up the doors. And so now it takes in the US about 2 days to travel from the East Coast to the West Coast. I'm not sure how long it takes if you drive nonstop, but I have some friends that have done it in 2 days. So the other way that what we wanted to do is to provide the infrastructure like that highway system that got people to where they wanted to go, and that covered 75% of their destinations. So not everything. And then it was very standardized. And so we built that infrastructure at one site, then we go to the next site, and the next site. And we spent 5 years doing the same thing over and over again. And we did not deviate. And it takes a lot of patience and I think a lot of belief in the long-term vision that this is the right direction, because most people that are having these pilot purgatory examples, they're maybe in a role for 2 to 3 years, and they start something and they get a couple wins and then kind of fades away. It never sticks. And then they move on to the next role. And so we had to be laser focused for a very long period of time building that foundation. But now in modern times, what we found is that by being intentional with our strategy, we kind of set aside those 25% use cases. So when we think about self-service analytics, so let's say an engineer has an idea of a calculation they want to do, or they just want to go and explore, and they're curious about their data. And we provided them a lot of analytics, kind of, spoon-fed to them, but it doesn't solve everything. And so what we found, unfortunately, is the engineers go back to Excel, and they're sitting in Excel trying to solve those ad hoc use cases. And what I think in the industry you need an approach to both. And I don't think that there is if you find one solution that handles all your governance and your standardization and your structure, and it simultaneously handles all of your self-service needs and provides infinite flexibility, I don't think that exists, and I don't think it's practical. So if you think about the interstate system, you have these vehicles that we drive, and it gets us to majority of our major destinations. And then you have your major interstates, and then you have the little, city roads, but it doesn't get you to every single place that you need to go. And so in some cases you might need a four-wheeler or a kayak or a boat or a dirt bike, or maybe you need to just walk to your destination. So I think you need to have two approaches. At least that's my take on it, is thinking about, how do I standardize the majority of our digital needs, and then at least from a data analytics perspective. And then also, I think you have to think about, how can I enable people with some flexibility to eliminate the cost of curiosity, to be able to go and just explore. And so one of the ways that we're looking at doing that is recently we started to work with Seek at some of our sites, and they're an advanced analytics solution, and they're really great in the self-service side. And so they kind of pull the engineers out of Excel, and so we have the PI system with asset framework, and it's very organized and very structured, and there's a lot of governance around it. And then there's another application where the Seek application, where they can go and do whatever they want. and there's less risk, to how that system will impact the global system.
Oh yeah, awesome stuff. So I mean, you I mean, throughout what we have discussed so far, you brought out brought up some interesting technologies or platforms rather. So you have got um, Databricks, Data Lake, and you've got your unified namespace, and then you've got your OSI PI. So I want to kind of like get a sense, of what role, especially for our audience. Our audience is more of a unified namespace background, and for a lot of them, they don't view OSI PI as being the unified namespace, right? They view, some other system as being a unified namespace, and then some others would, say your unified namespace is in, your Databricks is in the cloud, and things like that. I want to get your sense on how do you view the role of the unified namespace? What to you is the unified namespace, and what role is it, defined to play, and what role does OSI PI play, and what role does the data lake play?
That's a very good question, and I'm what I would say the unified namespace is a concept, and what I would think of it as a standard. Right now, there hasn't been a standard written yet, but that's how I approach it personally. Is treat it like a standard, and so think about all your business cases that you need to do analytics on or use manufacturing data on, and the unified namespace is a way of organizing those and connecting them. And that's that semantic model. And that will, so there's lots of different ways that you could do that. Theoretically, you could go and do that in Excel, maybe. I don't know. There's a lot of really, really great Excel wizards out there that I'm sure they could. I probably wouldn't encourage you to do that. But so for me personally, unified namespace right now is a concept, eventually should be a global standard across all of manufacturing. And within that, it lays that foundation, and it's independent of a specific software vendor. So while we are big believers in the PI system, and now realize on the PI system, there are multiple softwares in this. So you have the legacy OSI PI, as people think, the data archive, and it stores time series data, and it's tag based. So each instrument has a tag, and it has a timestamp and a value. That's all it saves. And then you might have some configuration settings on how frequently you save that data and your compression exception settings. So what we use on the PI system is something different. That is where we use the asset framework system. And you don't have to use the asset framework system if you're not a PI customer. But that is our for us, our unified namespace for our manufacturing data that's already in the PI system. But for really, unified namespace is a concept. So we're actually branching that out broader outside of just the process data. And now over the past 6 to 12 months, we've been thinking about more manufacturing data, and how do we contextualize and organize that? So all these things I talked about are shift turnovers, are maintenance work orders from SAP, and there's lots of information around that is not in our time series data historian. So for us, maybe we are looking at Databricks to do that. But really, I think people should first think about the business cases. What problems are you trying to solve? And not just right now. I think you got to think 5 to 10 years out. What are all the problems that you're going to solve? Because when you're designing a network, an architecture, if you're field of vision is only, within the next 3 months or only within the next 6 months, you're going to miss the mark. You just can't do it. So you have to think about, like Eisenhower did with his team, you have to think about the entire, for us in the US, the United States, and you have to think about all 50 states, and you have to think about, all the different cities and where the people are moving and where the mountains are and the rivers and the lakes, and navigating either through the mountains or around them, or build a bridge over a river. So I think having people extend their time horizon. So what we say is that we want to think, instead of incrementally, we want to think exponentially. And what that means is people want to just slowly increment their digital solutions. And that means that you build something, and then the next day you build something just a little bit more and a little bit more. But it's linear. But you see progress at the beginning. But if you can delay your progress and do some planning, and so this gets into project management, but you delay it, then what happens is you start to, once you start to build the system, the infrastructure you lay allows you to go 10 times faster. And that's where we find that we start to benefit from the economies of scale, and you benefit from the concepts around compounding interest. But there's this period where if you're looking in the first year, the incremental people are going to be winning and beating the exponential people. But people really overestimate what they can do in 3 to 6 months, but they wildly underestimate what they can do over 3 to 5 to 10 years.
Oh yeah, absolutely. So I want to, linger on that issue of, scalability and, how to sort of like scale. So the first, thing that I want you to, talk to us about is, so you mentioned this, that you sort of like, pick like 75% of use cases to sort of like proceed with, or was it the other way around, 25%? I want to get a sense of what criteria do you use, to determine which sort of like experiments do you do away with, and which ones do you sort of like promote into things that you want to be able to scale? So to use your example of the interstate highway, so they sort of obviously looked at these, things like, is there, what's the size of the population for this city, and all these examples that you gave us, right? So they did have some sort of criteria. In your case, are you able to share some sort of criteria that you're using to determine where you build those interstate highways? Which ones do you promote to scale?
Yeah. Let me see if I can get there. But in my mind, it's a very simple question. And I say, can you scale it? And if the answer is no, then move it aside. And if the answer is yes, then include it. And if the answer is I don't know, well, then that's a different question. And so now we talk about what business problems can scale and what can't. And unfortunately, I don't know your the viewers' organization and their tech stack and all their business needs. But I mean, for us, we have a wide range of manufacturing processes: batch, continuous, semi-batch. We have it. Most of our processes have about 50-50 split, and they'll go batch, continuous. And we have a wide range of unit operations: distillation columns, batch reactors, continuous reactors, batch filtration, continuous filtration, strippers, and heat exchanging, and you name it, we have it. And so what we did is we looked at all of those, and I'll give some advice for people. Yep. So first, think about the use cases, and you should define your hierarchies, the multiple ones, like the production one, the maintenance one. define all of them at the beginning and lay out the mapping of every single piece of equipment on that site. And you could just do this in Excel spreadsheet. We did that. And then you import it into your solution. But it's an easy way. I mean, conceptually, but it takes a long time. So when we do an implementation, before we actually start typing and configuring anything in the system, usually 3 to 6 months before that, we start that hierarchy definition. And we work with we'll get some site champions that understand the process, and then we understand the standard. And a lot of times we understand some of their process, and then what we do is they divvy out that work to lay out that whole hierarchy. And we have a standard of, okay, when should this equipment be at what level? And we help them with those types of decisions. And we help them with that. So you should lay it all out, because that is your major interstate system. It's like the spot where most of the traffic moves at the bulk. So then when you're thinking about your different use cases, for us, you have things like reporting. There are tons of different reports: environmental reporting, production reporting, whether it's shift reporting. You might have raw material utilization, end of month reporting. It goes on and on. So in our global program, we said we are not going, there's so many reports out there that we're not going to go there and replace every report in the system. We're going to build the foundation, and then the sites can then go and redo those reports, as they need. So we didn't break their solution, because the reports are already using the same data archive. And over time, they have built those into the system. So what we said is we focused on the analytics business cases. And if we want to analyze your process, what we want to do is, if I go back to that concept around the interstate system, and you have this network of roads that you're going to travel on, the next thing we wanted to do is to say, how do we get people driving on those roads and navigating them the same way, whether you're in the United States, or whether you're in Europe, or whether you're in South America or China or Australia. And so for us, we wanted to basically build like a Google Maps. So the concept was, doesn't matter what car you're driving, it doesn't matter what country you're in, and it doesn't matter what direction you're heading. When you pull up Google Maps and you're in your car, it looks the same everywhere. And it's the little blue little arrow thing right at the bottom, and you got a blue line of the direction that you're going, and it has a time of where how long until you get there. And that is so useful. I mean, I remember when I got my driver's license before Google Maps was around, and I remember having to pull off on the side of the road and go into a gas station and ask them I had to purchase a map. And I remember going back in my car and pulling out the map and like finding my location and finding where I wanted to be and like highlighting it. Yeah. I mean, I haven't done that in 20 years or something. And so we wanted to have this Google Map concept of, where is our process heading? And are we going in the right direction? Are we going to get there in the right time? But we wanted it to look the same everywhere. So what we did is we said, we want to scale statistical process control globally. And when people think about statistical process control as like a modern scalable digital transformation option, they don't, because SPC has been around for 100 years. And so we have been doing SPC, but for some reason our process, we're not all still in control. And we just found that people were doing it in limited fashion. They were all doing SPC a lot of times on their own personal computers, maybe in Minitab or something, when they and maybe a few people would create those graphics whenever they needed them. But what if every signal in your process was on an SPC chart, like a Google Maps, and you had these blue dots when you were going in the right direction, and then when you were outside your upper control or your lower control, they turn red, and you're outside of your lane. And how can you feed your data and your insights in that format and format it the same way for everybody? And so that's what we did, is we created the analytics highway, and then the analytics lens of how you look at all process data. Now, not everything, but about maybe 75% of it. And so we pre-built that. And the way that we were able to do that is we defined that as a goal. And then we went backwards and said, okay, if we want to look at this pressure in this lens, we want to look at this flow in this lens, we want to look at this level in this lens, we want to look at this utilization rate in this lens. How do we do that? And we worked our way backwards. And what we found is that there's a lot of common patterns that you end up finding in these different use cases. So by working your way backwards and you find the patterns, you standardize around the patterns. So the top two patterns is your process a batch process or a continuous process? And so we would bucket everything into there. So every time we added a piece of equipment or a unit operation into the hierarchy, you would say, is this batch or is it continuous? Now, sometimes you get into some semi-batch situations, and we have a special case clause that covers that. But 98% were those two things. And then how we grabbed that data would fit into two buckets. So if it's a continuous process, we would sample the data once every hour. And we would typically grab like the averages as a starting place, because we could scale that. We'd say, okay, you already have defined all your instruments and your data in this unit operation. And I want to grab it maybe I want to grab it every 60 minutes as a sample, because I want a long view of my process. We already have our process trends that look at 12 hours of data for our shift, the raw process data signals. That's for us in the PI vision system. But we wanted a longer term 3-month look at our process to help us steer and navigate how we're making decisions in, improving yields or production throughput or capacity or quality. So we did that for continuous. And then for the batch, we said, okay, well, we want to monitor all these key inflection points in a batch process. And what we would do is we organize that by the different phases and sequences. So if you have a batch reactor and you have a heat up phase, and then you have a raw material feed phase, and then raw material 2 feed phase, then you have a reaction phase, and then maybe a cool down phase, and then maybe a transfer phase where you're sending it out to the next unit operation. So we would grab and sample the data in those buckets, and then we'd organize all that where we'd have one row of data that's one batch, and it had all this sampled information, and we would compare that against hundreds or thousands of batches. And so then we could look at that level within that phase in a certain context over that batch and the previous batch and the other batch. And by doing that, we put everything into the same lens, and we were, able to pre-generate those. And the benefit of scaling that is the identity and how you formatted the data was 2 options. And we've done globally, I don't know, thousands and thousands and thousands of unit operations and tens of thousands of equipment in that same way. So that's I could go on and on. We have a deep standard that covers that, but maybe that's helpful for somebody watching.
Oh yeah, absolutely. I mean, that's really lots of useful information here. Thank you so much for really going into depth regarding that. So I mean, as you mentioned, another dimension of scale is operator and engineer buy-in, right? As you mentioned, a lot of people do resort to solving things the way they've known, how to. Some, revert back to Excel, some go back to, doing it on their laptops. So I wanted to kind of get a sense from you on what tactics helped you sort of like, turn your frontline teams into champions rather than skeptics.
We've been talking about data the entire time, but this is the hardest challenge in manufacturing. And there is no perfect solution for this. I think on the data side, eventually you'll get to like this is the because it's all zeros and ones, it's a kind of like it's data, and eventually you can get to this is the truth. On the people side, I don't think you'll ever get there. And so for us, we found that if we only focus on giving tools to the engineers to do analysis, you can do that, and you can get value from doing that. But you have to think about what happens when the engineers are not there on nights and weekends. What happens when that engineer moves to a different role? And so what we wanted to do is we thought about what does the future of manufacturing look like in 10 years or 20 years? And should the engineer still be responsible for troubleshooting every single, issue in the process? And how do we upskill our operators to act like engineers? How do we give them better tools to handle those issues on their own? And so we put deep focus on the front line, and we said our goal is to unlock their potential. That's where our focus was. And so because of that, when we would do a technology implementation, you build the solution and the whole scale of the site maybe in three months, maybe up to 6 months or something. But then we may spend 6 to 12 months with all these different management systems and working and building relationships and change management. And at the beginning, we did not do that. We really underinvested in change management. Even though we did have a change management scope, we knew that it was important at the beginning. And I just wildly underestimated it. And so we had this one site where we actually built the solution, and the first site, they used it. Great. The next site, we built the same solution. They didn't use it. But the solution was the same. So we actually came back a year later, and we didn't change the technology. We only focused on enabling the people, listening to them, working with them side by side. So we'd spend many months working with them and figure out, how do you integrate this new tool into how they do work, and how do you meet their needs? But also you got to have some structure and some standardization around it. They can't do whatever they want. But I think you want to work and craft the solution with them and teach them and coach them. And it's important. The relationship piece is just unbelievably important. And so by doing that, when we went back to that site very shortly after they started using it, and their ROI was like, just went off the charts. And so, and the technology didn't change. And it was only on the people side. So, and once they start to use it and you build that momentum, we wanted the technology to not be a roadblock. We didn't want our engineers building solutions. We wanted our engineers to work with the operators to use what we built to solve problems. And that was our main goal, is upskilling the operator and using the engineers to facilitate that. And the technology was saying, where are the operators and engineers spending their time hunting through all these signals and trying to find insights? And what if you just did that for them? You've spoon-fed it to them. You gave them Google Maps and said, this is where your process is going. Now you've got to make a decision. You got to take an action. Do you turn right or do you turn left? And so that's really what we focused on is how do we use technology to remove all those barriers and focus and the engineer's time with focusing on the operator and enabling them to make quick decisions, to take action. And so when we built these solutions, we didn't build dashboards, we built action boards. So we actually forbid the term dashboard internally. I forbid it. And technically they're the same thing, but the meaning behind them is so much different. Because if you're going to put an insight on an action board, by definition, it requires action. So sometimes people just create insights in these analytics because they're interesting, but they don't think through the next step. What action should we take? And are the end users of that, maybe the people on your shop floor, are they enabled to take that action? Do they have the ability to do it? Are they trained on it? Do they understand what the insight is telling them? Do they understand the direction that the process is heading? And so by being able to shift that focus on the shop floor and invest in the people and use technology as just a barrier removal element, that's where we found tremendous value.
Oh man, there's just so much to talk about, so much valuable information that you're picking for us here, Jonathan. But so little time that we have left here. But I want to kind of like before I let you go, get your sense on what can you give as advice to manufacturing leaders out there who are maybe just starting out on this journey, or maybe who are in this journey of really trying out the pilot. How should they, you know, basic advice on how they should approach this, or what should they look out for importantly?
So your question is, what advice do I have for people who are stuck in
Yeah.
pilot purgatory or just beginning?
Yeah.
My
So
advice would be different.
let's focus on pilot purgatory.
Okay. My advice is going to, unfortunately, I'm going to say it depends, but I'll give some context here.
Mhm.
So if you are, let's say, an engineer and you're at a local site and you don't have a big budget, you don't have a big team of people, what do you do? Are you going to be able to build a big global solution and do a big implementation like that? Probably not. Now, maybe you can, build a big following internally and you can kind of champion it. And over time, you can get there. But what I would say is think about what you can do and just do it great. So if you're in that lens where you're an engineer and your influence ability is within a certain bucket, and your resources and budget are within that bucket, make that bucket great. And what I would say is focus on the business value and focus on the end user, and don't focus on the technology. Now you need the technology, but like you need to prioritize the end user, the actions that you need to take, and think through that. And I think if you do that, what will happen is you will start to deliver ROI. You will start to create champions in your organization from people on the shop floor. They will start to have stories that you can start to share internally. And over time, that builds momentum. And you want good momentum. Now, if you're on the other side and you've been in pilot purgatory for a long time, you're just starting your digital transformation journey. Well, I think what you should, the biggest advice I would give is maybe the same. So think about the end user. If you stop at the technology, don't underinvest in change management. But really, I think extending your time horizon and spending a lot of time in that early design phase.
Thank you so much for taking the time to share your deep insights with our audience today. I really appreciate it, your participation here today.
Yeah, well, Kudzai, I really appreciate it, and thank you so much for the opportunity. You know, I'm as you can tell, I'm very passionate about this topic, and it's very exciting for me. I'm excited for the industry because we're doing great things, and there's so much potential to be unlocked. It's incredible, and we've been doing great things for decades. And I think with the surge in AI at the moment, it's even more exciting. It's unlocking more opportunity, and manufacturing's in a really great spot to really plow into new frontiers. And I think there's a lot of opportunities right now, and there's just a tremendous amount for the next generation. So that gives me a lot of energy, and I'm very optimistic about the future of manufacturing.
Oh yes, absolutely. Really appreciate having people like yourself who are, open to share all of this with the people that are still, coming up or also on that same journey as yourself. So again, thank you so much for taking the time. We're going to provide links to your socials and all the other places that you can be found on online for those who want to reach out to you. So again, thanks.
All right. Thanks, Kudzai.